Which graph has two parallel lines, and which graph has two perpendicular lines? Parallel lines are lines that never intersect. So in answering that question, I look at the two graphs in both A and B, and look for the lines that don't intersect. They run parallel to each other. They run side by side, never getting closer, never getting farther apart. And I can see in part B that part B has the parallel lines. On the other hand, perpendicular lines are lines that intersect at a 90-degree angle. Looking at the lines in part A, I see that these lines intersect at a 90-degree angle, telling me that they are perpendicular. One concept that will be investigated later is the fact that you can't always judge whether lines meet at a 90-degree angle based on the graph. If I were to change the scales on one of the axes, it distorts the graph and might make something appear to be perpendicular, even if they're not. One complication recognizing parallel lines in graphs is that lines might appear to be parallel, even though they're not. Some slopes are so close, like a slope of 1/2 is very close to a slope of 2/5, and you might not visually be able to distinguish between the two just by looking at the graph. What we need is a more definitive way of identifying whether lines are actually parallel or perpendicular. So let's begin with the parallel lines. Part B had the parallel lines. We recognize that because the lines ran side by side, never getting closer, never getting farther apart. Well, part D asks, what are the slopes of these two lines? If we pick 2 points on these lines, so on line 3, I'll pick the point -1, 1, and 2, 3. I picked those 2 points because they fell nicely on the grid behind the picture. I can see to get from the point -1, 1 to the point 2, 3, I will need to move right 3 units, giving me a run of 3, and I will need to move up 2 units, giving me a rise of 2. So for line 3, I can see that the slope is 2/3. On the other hand, looking at line 4, I see there's a point here at -5, -5, and a second point at 1, -1. And so to get from -5, -5 to the point at 1, -1, I will need to move to the right 6 units, and I will need to move up 4 units. And so that gives me a slope of 4/6, but reducing that fraction, I see that I have a slope of 2/3. So I would finish part D with a sentence answer. What is the slope of line 3 of line 4? I would say the slope of line 3, L3, and line 4 is 2/3. This brings us to a more general question. How are the slopes of parallel lines related? Well, to be parallel, to not get closer or farther apart at any point along the line, the slopes of parallel lines must be the same. So parallel lines must have the same slope. Now we turn our attention to the graph that had perpendicular lines. We know that these lines meet at a 90-degree angle, but part C on this question is to find the slope of each of those two lines on their own. So for line 1, I see there's a point at -5, -5, and another point at -2, -3. So for line 1, I can see that to get from -5, -5 to -2, -3, I need to move to the right 3 points, and I need to move up 2 points. So the slope of that line is 2/3. On the other hand, on line 2, there's a nice point at -3, 5, and another point at -1, 2. To get from -3, 5 to -1, 2, I will need to move right 2 units, and I will need to move down 3 units. So I will have a rise of -3 and a run of 2. So to answer part C, what is the slope of line 1? The slope of line 1 is 2/3. And the slope of line 2 is -3/2. So the final question in this example, how are the slopes of perpendicular lines related? Well, you'll notice to be perpendicular, one line needs to be an increasing line, while the other is a decreasing line. So they're going to have opposite signs. But additionally, notice that one slope is 2/3, and the other is -3/2. So the quick way we state that both the signs have to be opposites and the fractions need to be reciprocals is to state this. The slopes of perpendicular lines are opposite reciprocals. The slopes of perpendicular lines are opposite, meaning opposite sign, and reciprocals. The fraction has been flipped upside down. It's also important to notice that if you actually multiply 2/3 times -3/2, a positive times a negative will be negative, and you'll end up with 6/6, which is -1. So there's actually two ways you can identify that two lines are perpendicular. One is to look at the slopes and recognize that they are opposite sign and reciprocals. The other is to multiply the two slopes together and to verify that you do actually obtain -1.